Okay, so now let's consider what happens if I have another force that's acting, sort of more like what you had on problem number 5 in the homework. So here if I have, oh, pardon me, here if I have an inclined plane, I have an object sitting on it, and then let's say we have some extra forces. But first we have all those normal forces, right? I have the normal force, or I have the usual forces rather. I have the normal force there, I have the force weight here, and then let's say that we have a frictional force. Now, we want to ask ourselves, if we have a frictional force, what direction is it moving? So for example, if I have a force, if the block is just stationary on the inclined plane, then the frictional force will be in this direction, and it will be a static frictional force. That's if it's stationary, because you know what? The block, it wants to move in this direction. It wants to move with a velocity or an acceleration in that direction. And because it's stationary, that means the static frictional force is in that direction. In fact, if it's moving up the inclined plane, which we can have, get rid of this. So this is only if it's stationary and you have a homework problem like this. But what if there's another force that's moving up the inclined plane? So we have some force that's pulling, and we have frictional force that is opposing. So in this case, our block would be moving, accelerating up the inclined plane. Let's consider this problem, and we'll just set it up. I'm not going to put in any numbers because you have homework problems that are like this, but let me sort of go over the basics. Now remember again, we're going to draw our coordinate system. We're going to draw our x-axis along the plane, and the y-axis perpendicular to the plane. I'm going to call this 30 degrees. That would mean that this angle is 60 degrees. Now, all of our vectors are on either the x or the y-axis, except for that one. So I'm going to draw them. I'm going to have my normal force here, Fn. I'm going to have my force F. This is like a force that you're pulling the block up. Say you have a cable tied to it, or you have some force being applied to it, or whatever. Then I have Fk here. And then I have this weight. I'm going to go ahead and resolve it into its x and its y components. So this is Fw sine of 60. And then this is Fw cosine of 60. Well, let's say that I know this force. Okay, that makes it solvable, basically. Then I apply my Newton's second law. Sum of the forces in the y direction is equal to 0. Remember, like I said in the previous one, that the y direction, it never moves in the y direction because it'd be coming off the inclined plane. You'd have a completely different problem if that was the case. So the sum of the forces in the y, normal force in the positive y direction, minus Fw sine of 60, that's equal to 0. So if you needed to know your normal force, I would just say Fn is equal to Fw sine of 60. And then you could solve that for whatever number it is. Whatever the mass times the acceleration due to gravity times the sine of 60 would give you your normal force. Then the x direction is a little trickier. We say Fw cosine 60 plus Fk minus F is equal to MAX. Okay? I'm going to give myself a little space here to solve this. I'm going to do it down here. Because notice here that I have some unknowns. Right? I'm presuming that I know this and I know this. But my unknowns, or here I'll put this, I know this and I know this in green. But my unknowns are the kinetic friction and the acceleration. But notice that I know the kinetic friction because I know that the kinetic friction is equal to mu k times the normal force. I know this because I solved for it right over here. And so I can find out what is my kinetic friction, and then I can plug it in right here. And then I'm just left with the acceleration. So I just say the acceleration in the x direction Well, let me take care of this. The acceleration in the x direction is solving that is just FW, that's mg, cosine 60 plus FK minus F divided by M. I know all those values, they're all given, or I've calculated them, for example, up here, and I can solve it. That's a good example of what you might see. Look back on the old test, you can also find an example. A good problem I like to give is, what if you have a block on an inclined plane? It has a certain mass, I don't know, say 5 kilograms. Let's say this angle is 60 degrees. What must mu s be in order for this to stay on the inclined plane? Well, think about the forces that I have. I have the normal force, Fn. I have the static frictional force, Fs. And I have the weight, Fw. All right, I know that Fs is equal to mu s times the normal force. So in order to figure out mu s, I have to figure out Fs and the normal force. Well, look, I know the normal force. Here's my Fwy, that's Fw sine of 30. Here's Fwx, that's Fw cosine of 30. I know that the normal force is equal to Fwy, the y component of that weight. Further, I know that the static frictional force is equal to Fwx, the x component of the weight. So I can just take the ratio of those. I can say Fs over Fn, and that's going to give me my mu. Listen, there's a homework problem like this. I think there's a homework problem. There are also some old test problems. I would certainly take a look at those, okay? So again, the big things are, make sure that you get your axes right, your coordinate systems right. Make sure that you get your angle right. Make sure that you resolve these vectors correctly. And then applying Newton's second law, taking the vector sum in the y direction, taking the vector sum in the x direction, and noting whether or not it's a static or dynamic situation. Always, always, always in the y direction, it will be static, so that this is equal to 0. Sometimes in the x direction, a will be 0, and sometimes it will not be 0. You'll just have to read the problem and figure it out. If it says it's moving, well, ax is not 0. If it says it's stationary, well, ax is 0. It's not really that hard to figure it out. Just look for those key words. Stationary, it's moving. Also look, maybe there'll be some mention of either kinetic or static friction. These are tough problems, but they're also good problems. They test your knowledge of vectors. They test your knowledge of how to deal with vectors in 2 dimensions.